So Bits to Waves is it's a one-day course that's focused on trying to teach the overall system concept of radios and also give people the experience of building something. Because one of the things that's been missing in education has been the ability to actually fabricate and build something up. Because today, with the wonderful CAD tools that are out there, we tend to design everything, and then we hit go and somebody else fabricates and makes it. And we lose touch with how things are made, and we also lose sort of the joy in building something ourselves and seeing it work and getting in touch with the actual final product. The class also teaches from an experiential standpoint. So instead of listening to a lecture about how something might work, we actually design. We do a complete layout, we do EM extraction, we fabricate the boards, we populate the boards, and we test them. So you get to go through the entire flow of an actual problem, and that tends to be a lot more effective for people to learn and a lot more fun also.
Let's talk a little bit about the radio that you're going to build. The architecture is a direct conversion transmitter. So you are going to be provided with an I and a Q signal and an LO. What you're going to do is you're going to take that LO and create a sine and cosine, or sine and cosine. You're going to build two mixers, you're going to build a combiner, and then you're going to build a power amplifier and an antenna. This diagram shows two amplifiers, but we're just going to be doing one. Like there are I and Q mixers, there's a Wilkinson combiner, there's a phase splitter to create 0 and 90 degrees, which is the branch line coupler we'll talk about, a power amplifier, the receiver has an LNA, and then both of these have antennas. So these are the different pieces. You're going to be building just the transmitter, so you'll be building everything except for the LNA. All right, here's me assembling the radio with my 4 components. Here's a integrated version, but here are the 4 pieces. So I'm simply taking some connectors, putting it on my branch line, then I'm connecting it up to my 2 mixers, and then noticing that everything lines up. I recommend that you line these up and loosely assemble and then tighten them as I'm doing now. There you go. There we are. There's my 16 QAM constellation, and I'm just using the X versus Y plot on the scope to plot the I and Q. All right, here we are on the website. This is just an introduction that we've already covered in our video so far. I just want to point out to the right, there's a nice drop down where this will take you to each one of the designs, and it will also take you to a theory page that will explain the construction and how each of the components work. We're going to go back to the introduction page, but before we do, I just want you to note that I've actually numbered all the components in order of completion. Start with the Wilkinson, 1, then the branch line, then the mixer, then the power amplifier, then your antenna. And note that we're not using the oscillator in the workshop. I'm going to go back here to the introduction, and we're going to click on the start, and it's going to take me to this page. And this is very important because this is where you're going to download the template. Once you've downloaded it, we can go ahead and get started. This is the complete radio. Once again, I'm mentioning that these need to line up. This is a picture of the test that we'll actually do in the workshop, our student design competition. Here's an example radio. You can see the branch line, the 2 mixers, the Wilkinson, the PA. It's connected to the antenna. This is the part that you will design. When we actually do the testing, we will provide a receiving antenna, and then a receiver demodulator is off to the right. Continue on to the design page, and here we are. Here are the 5 components, 1, 2, 3, 4, 5 that you should make, and each one of them will take you to the same page that each of these take you to. This will take you to designing the Wilkinson combiner, the branchline coupler, the double balance mixer, and the antenna. Let's just go to one of these pages to make sure we understand how the pages work. So this page will take you through how to set up and operate the branchline coupler. If you've never used AWR before, it only takes a couple minutes to learn how to use the software, and then we walk you through telling you every command that you need to create as you flow through here. And as you can see, we go step by step helping you understand how each part works. I'm just going to scroll down to the bottom. And we also tell you how to assemble. And this is just pictures on the foil technique I mentioned to you, where the foil is stuck on. And then we also tell you how to assemble and how to test the individual components.
So now I'd like to go over what you should be doing before the workshop starts, ideally tonight. First of all, you'll be given a USB. You may have to share one with one of your friends, but simply copy all of the files from the USB and install the AWR software on your laptop. Note you need a 64-bit laptop for the software to work. Then go through the simple tutorial that'll be handed out to you. You'll do a simple schematic design, and it'll take you about 15 minutes, but it'll get you ready for tomorrow. You can then go to my website and start designing right away, or tomorrow at the student school we'll design together. The build will be at 8:30 on Wednesday. I'm really looking forward to seeing you all there. Good luck.